Okay, so next example is something different. 1 to the infinity. Okay, the base is pulling me towards 1. Oopsie daisy. Whereas the exponent is pulling me towards infinity. Okay, so there is a tug of war happening here, which we have to resolve. Same procedure as before. I let this equal y, and I look at ln y. Okay, when you do ln y, the exponent, which was here, moves down. So the whole point of using the logarithmic technique. And then you get a fraction, which is good. Good, because L'Hopital needs fractions. Oh. Okay, pause and copy this. Now I'm going to find limit of ln y. Okay, thankfully that's a fraction. Use L'Hopital. Ugly, but when I simplify, I get something which is pleasing. 4/1. I have resolved this difficulty. So that's just 4. Now, as I mentioned before, because we found lim ln y here, we're just taking this number and sticking it as an exponent on e. Okay, a couple exercises for you to try. So pause, copy, try. Pause, copy, try. Okay, this example is a kind of a warning to you. Okay, 95% of the time, 99% of the time, let's say, if you have infinity over infinity, L'Hopital's rule will be right as rain. But 1% of the time, something strange happens. Okay, in this case, if you think about taking the derivative of this, you get 1. Derivative of this, you get this. Okay, this limit does not exist though. Okay, this was a stipulation in the L'Hopital's rule that I gave you above. Okay, we need this limit to exist or equal plus infinity or minus infinity. This limit here does not exist. Why not? If you think about this quantity here, cosine is just waving forever, right? So this cosine is waving forever. So this quantity does not approach anything as x goes to infinity. It just kind of waves forever. Okay, so that is not good. So we can't use L'Hopital's rule because, as you'll remember, we require that this limit exist or be plus infinity or minus infinity. Okay, it can't be one of these wavy things. Anywho, what do we do instead? Well, we go back to our Cal 1 techniques. Okay, I'm going to divide top and bottom by x. And that'll work out. Okay, when I divide top and bottom by x, I get this item appearing here. Now, the limit of that item is indeed 0. Okay, there's no worries about the wave property of sine. Okay, sure, sine, x is going to infinity still, and sine is waving forever, but it is getting smushed. It's getting smushed by this division by x. Okay, the x is going to overwhelm the the wave, so to speak, okay, and bring it down to zero. That's kind of a qualitative way to think about it. No, that's the idea. Okay, you may have shown this using squeeze theorem last semester.